Good afternoon. This is Ward Harriman, AE6TY. Today's topic is adding custom calibration to your older antenna analyzer. Many older analyzers don't have the ability to do a custom calibration. They rely solely on the factory calibration. And sometimes that's inadequate, or you want to do something a little more sophisticated. This video will show you how you can do that. So here's what we want to do. We want to add custom calibration, and we're going to use SimSmith to do it. Here's an older antenna analyzer. I'm going to have a feed line and an antenna up here. And I might want to calibrate out this feed line, maybe calibrate out some internal errors here. And that's what today's project is going to be doing. So a little housekeeping before I get started. To do this, you probably are going to want to upgrade to at least 18.4 build F, which is available on the website. And the first thing I want to do is to go get the samples directory, or the samples. Clicking help, we want to fetch this zip file. I'm just going to store it in my home directory. You can put it wherever you want. And then I'm going to come and unzip it. I right click on this, I say unzip. And this file is no longer needed, so I'm just going to delete it. Now, down inside that directory, there's an example, which is the directory in which I'm going to be doing this demo. It might have files in it already, and if there are, I'm going to get rid of them. So I want to get rid of this. So now I have a fairly empty directory. I'm going to use these in a little while. Now, what is it that we're trying to do? What we're trying to do is to get rid of that feed line and any errors that might be there. Now, this would be using a real antenna analyzer and real antenna and real feed line, but for the purposes of this demo, I'm going to be using SimSmith to simulate each and every one of the pieces. Please remember that this is not just a simulation. You can do this with real data. And hopefully that will be obvious by the end of this video. So the first thing I want to do is to come up with something that's at least superficially like a real antenna. And my favorite model looks like this. And let's go over a fairly wide frequency range. So here's my sweep. I just want to look at the sweep, and this isn't quite as representative as I might like, so I'm going to increase the losses here to cause a little variation with frequency, and I'm going to add a little capacitance. So it looks a little more like an antenna might look. So this is going to be my antenna model, and I'm going to use it to represent what would really be my antenna for the rest of this simulation. So I want to write out this to be what the actual antenna So now I don't need this anymore. And I can use that file here. So this is what ideally I would like to see at the end of negating my feed line and any errors that might have cropped into my antenna analyzer. So in the real world, I might have, say, a feed line, and I might have some errors, which I don't know. I'm going to use this block as errors. That's a black box. I'm not going to even look inside of it. And you can see here that our real antenna is supposed to look like this, but because of the feed line and those errors, it looks like this. So we can turn this off. And this is what I'm going to say you would actually have measured using your real antenna analyzer and looking through the errors and the feed line. So I'm going to save this, and this is what I'm going to call the raw measurement. So now the goal is to develop a mechanism by which I can extract or I can negate these things. And this is done using the normal short, open, and load measurement technique or calibration technique. And so you would use your real feed line and know that you have real errors, and you would use your real antenna analyzer to make the following measurements. And I'm going to do them here in SimSmith, but remember, this should be done in the real world. First thing I'm going to do is get rid of this. And I'm going to get rid of this. And there are 3 measurements that I need to make. One is if the output is shorted, so I would hook up my antenna analyzer to my feed line, and I would short the end of the feed line where the antenna would normally be, and I would record the impedance seen looking into here. So I'm going to say this is the shorted impedance. Now, I'm using S1P files, but they don't have to be. They could be CSV files or gamma files, whatever format your antenna analyzer might want to put out. So the other one is I need to measure it with an open. Now I'm going to say 1 gig, that's pretty open. And I want to save that again using my real antenna analyzer and my real feed line. I would open up the end of it, make a measurement, and record it. And the final one, of course, is the loaded version. I'm going to say 50 ohms. It doesn't have to be exact. It will be in simulation. In the real world, just get something really close to 50 ohms. And again, I need to save away that measurement. So I'm going to say that is the loaded version. So now I've made my actual measurement of my antenna, and then I've made 3 more measurements. One with the antenna replaced by a 50 ohm load, one with it replaced by a short, and one of it replaced with an open. And my goal is to develop a block that will deliver to me the actual impedance of the antenna with the feed line and errors taken away. So I'm going to get rid of this because I've fully characterized that. And I'm going to go back to my raw measurements. So this is what I saw raw, and I need to develop a block that will subtract out the feed line and the errors. I've already made that block. It's called a correction block. And for those people who want to look inside of it, this is what it looks like on the inside. There's a thing that describes how it should be drawn, and this is an N block. So it has 2 ports, and it does a bunch of calculations through here. And ultimately, it uses an S parameter block to subtract away the effect of the feed line. And it takes as input my short, open, and load. So I'm going to go in here, my short, my open and my load. And so now this block, using the measurements of a short, open, and load, can calculate away the effect of my feed line and my errors in my system. And this looks very much like what we started with. Let's do a direct comparison. So I can come down here, and I remember that I recorded this, so I'm going to actually just pull this over as a reference and drop it here. And of course, nothing new appeared because there's what the actual antenna was, my simulated antenna. And here's what my calculation looks like, having subtracted out the errors and the feed line. So, what did we do? Well, we made 4 measurements. We measured our original antenna through the feed line and the errors. We measured the short, the open, and the load, and we used a piece of mathematics to subtract out the feed line and the errors from the raw antenna measurement to deliver the impedance of the actual antenna. This is Ward Harriman, AE6TY, saying thanks for watching, and thanks for using SimSmith.